Hello guys, here Mr. G with another video for the Cretans. This time we're going to be doing question 8 from June 2013 done at the Northern Cape. That was set B. But before that, subscribe for the channel so you can get all the notifications and videos I post on regular basis. This question said, in the early 18th century, the Italy physicist Amadeo Avogadro studied the formation of H2O from hydrogen and oxygen. In this experiment, he allows hydrogen and oxygen to react at the temperature higher than the boiling point of water. At this temperature, the water forms in a gaseous phase. The equation for this reaction is as follows. Now, this question is quite important, at least for the learners at the Northern Cape, because I am sure they struggle to reach to this topic because of the timing. So please, let's have good attention. In this reaction, is this reaction homogeneous or heterogeneous? Give a reason for your answer. Now, what I want you to know, when a chemical reaction is homogeneous, when they have the same state, for instance, everything in the reaction is solid, or everything in the reaction is gas, or everything in the reaction is aqueous. That is when a reaction is homogeneous. When a chemical reaction is heterogeneous, when the substances are not in the same state. This would be the case when you have within the chemical reaction some solid and some aqueous and some gases. Now, in this specific reaction, you can see that everything are gases there. Use the color used for homogeneous. Everything is in gases. So this reaction is homogeneous. It's a homogeneous chemical reaction. Why? Because the substances are all within the same state. Everything is in same state. I'm going to write here same state, but it's the second time I'm writing, so I guess you are following me. And this one is question 8.1. Question 8.1 is quite simple. The valence chemical equation for this reaction, and they give you now a chemical reaction which is valent. Illustrate using sketch the three phases of water. Alright guys, and here is the representation for that one. This one is not 100% accurate, but this is the idea. Now, what I want you to know that what is a very tricky one. I don't know if there was the purpose of this question in this question paper, but what is tricky, because in the solid state water take up more space than in a liquid state, and that only happens with water. But more or less this is the idea of the representation. All you have to make sure is that in a solid state the particles are packed together, as it is there in this point here. They are packed together, and here they are not packed. They are liquid. They take in the shape of the container. That's all you need to make sure. But this one is a little bit tricky because water is a special case of a molecule. Now, question 8.3. Prove that the law of conservation of mass. Now, what does this law state? And this one is for those learners that couldn't finish this work. The conservation of mass means that the mass of the reactant, the total mass of the reactant, must be equal to the total mass of the product. So let's do that one real fast. So what we need to know that here everything that is on the left hand side is the reactant, and everything that is on the right hand side, it doesn't really matter how many substances are there, is going to be the product. Alright? And you need to know that the mass of the reactant must be equal to the mass of the product. So if that is the same, that is the law of conservation of mass. That is the law of conservation of mass. Now, how we do this? We're going to go to the periodic table, and we are going to find the mass of every element that is here. Now, here we are in the periodic table. Now, the atoms involved are hydrogen. Here is hydrogen. We're going to mark the atoms we are involving with, and oxygen. That are the only atoms involved in this chemical reaction there. Alright, so you need to know that the mass of these atoms are the numbers at the bottom. This is the mass. it is shown in this specific element there. So for hydrogen is 1 and for oxygen is 16, and we are going to go here, and remember we are going to calculate. So for reactants, let's fix this word, reactant. Now for reactant we have hydrogen, but we have, be careful, look here in the chemical reaction, we have 2 hydrogens at the front. It's a big 2, that 2 is for everything. I'm going to open bracket, and then I have 2 hydrogen inside the bracket, so it will be 2 times 1 because the mass of hydrogen was 1. So the 2 at the front is for everything. Now then it's coming a plus there, so everything here plus oxygen, but you have 2 oxygen, so it was 16 times 2. This is what we have to calculate for the reactant. So if you do this calculation, it's very simple calculation. So you get that is 4 plus 32, and this is equal to 36. Let's write here units, because it's not important the unit we're going to use for the right now. So this one was for the reactant, so we have to do now the same for the product. So for the product, what do we have in the product? We have water, but we have 2H2O. So we have a 2, remember it affects everything, bracket, and then inside the bracket I have hydrogen, which is 2 hydrogen, so it's 2 times 1 for hydrogen plus 16 from oxygen. And guys, this is all. This is simple math. So let's solve everything here first. What is inside the bracket? We have that 2 times 1 is 2, so open bracket is 2 plus 16, and this will be equal to, and this is equal to 36 units, guys. And you can see now that the mass of the reactant, I'm going to write it down here, the mass of reactants is equal to the mass of products. All right, there we go. Let's move all this one a little bit to the right. There we go. Mass of the reactant is equal to the mass of the products, guys. And this one is the law of conservation of mass they ask us to do. It's very, very simple. Now question 8.4 also is quite new for some learners. Classify the reaction as a physical or chemical change. Give a reason for your answer. Now this one here is a chemical change. Why is a chemical change? Because a new substance form with new properties. You can see that the new substance, water is a new substance, completely new, and then it is a new substance with different properties from oxygen and hydrogen, even though inside that substance there is oxygen and hydrogen, they are different ones. So we are going to quickly write here that one is a chemical change. So what do we have to say? Chemical change, because a substance with new properties is formed. It's very, very simple. And now classify the reaction as a synthesis or decomposition reaction and give a reason for your answer. Now before we go, let's just recall, because this one may also be new for some learners, guys. This video is a very important video. Now what is synthesis? That is when you have two reactants, for example A, and you add B, and then you will have a new reactant, which is the combination of the two, which in this case is going to be AB. This is synthesis. It's very, very simple. Now what is decomposition? Now decomposition is when you start with a substance, for instance AB, and that one go decomposed. It's broken into A plus B. So that is very simple. That is the difference between decomposition and synthesis. But now guys, here what we have in two reactants, there we go, that come together into one. So what is the correct answer then? Saying that one and showing you here which is the composition and synthesis. This is synthesis reaction. So the correct answer here is synthesis. It's very simple to identify. That one will be the correct answer for this one here. So what we have to say is that two reactants combine to form a new product. That is synthesis. I hope you are watching and I hope you understand. It is really, really important. Okay, so I know that many learners did not manage to do this one at school, so I hope it helped. This is a very important video. But thank you for watching. If you think it helped, thumb up, subscribe for the channel, and I'll see you next time. Mr. G here.